According to the National Fire Protection Association 70, also known as the National Electrical Code, installing 120 volts control conductors for motors with other 120 volts conductors in the same duct is permissible. Article 300.3c of the NEC states that control conductors shall be permitted to occupy the same raceway cable or enclosure with conductors of other circuits. Furthermore, Article 300.5d allows conductors of different systems, circuits, and voltages to occupy the same raceway cable, enclosed busbar, or cable bus, provided all conductors are insulated for the maximum voltage of any circuit therein. Regarding the maximum number of wires in a conduit, this is generally determined by the conduit size and fill calculations. For example, a 3-inch diameter conduit typically has a maximum fill of 40% for cables, which roughly corresponds to about 7 wires, depending on the specific size of the wires used. Some recommendations to consider: firstly, ensure that all wires are properly segregated and insulated to prevent short circuits. Secondly, use stranded conductors for control circuits to enhance flexibility and reduce the risk of damage. Thirdly, label all conductors clearly to facilitate easy identification and maintenance. Finally, consider utilizing a multi-conductor cable for the control conductors to minimize the number of individual wires. The 20% load adjustment for the motors does not affect the ability to install the control conductors in the same duct. It is critical to adhere to local electrical codes and, when necessary, seek advice from a qualified electrician. The primary considerations revolve around safety and compliance with the NEC. By adhering to the NEC guidelines outlined in Articles 300.3c and 300.5d, you can confidently combine control and power conductors within the same duct. Proper insulation and segregation play a vital role in preventing electrical faults and ensuring the longevity of the installation. When working with electrical systems, it's always better to prioritize safety and compliance with established standards. The selection of appropriate wire sizes, conduit dimensions, and insulation ratings contributes to a reliable and safe electrical installation. Always double-check the local regulations and any project-specific requirements that may apply to your installation. Combining control and power conductors can optimize space and reduce material costs, but it should never come at the expense of safety. The NEC provides a framework for achieving both efficiency and safety in electrical installations. The use of stranded conductors is especially valuable in control circuits due to their enhanced flexibility. Stranded conductors are less prone to breakage when subjected to bending and movement, which is common in control wiring applications. Labeling conductors is a simple yet essential practice that simplifies troubleshooting and maintenance. Clear and durable labels ensure that electricians can quickly identify the function of each conductor, saving time and preventing errors. Multi-conductor cables offer a convenient way to bundle control conductors together, reducing the overall number of individual wires in the conduit. This can simplify installation and reduce the potential for clutter within the conduit. When working with multiple circuits in the same conduit, it's important to consider the potential for electromagnetic interference. Properly shielding control conductors can minimize the risk of interference and ensure reliable operation of the control system. The NEC provides detailed guidance on conductor sizing and conduit fill calculations to ensure that the electrical system operates safely and efficiently. These calculations take into account factors such as conductor ampacity, ambient temperature, and conduit dating. In addition to the NEC, local electrical codes may impose additional requirements or restrictions on electrical installations. It's essential to familiarize yourself with the local codes and regulations before beginning any electrical work. Consulting with a qualified electrician can help ensure that your electrical installation meets all applicable safety and code requirements. Electricians possess the knowledge and experience to identify potential hazards and recommend appropriate solutions. When working with underground ducts, it's important to consider the effects of moisture and corrosion. Using moisture-resistant conductors and corrosion-resistant conduit can help extend the life of the installation. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC provides detailed requirements for grounding electrical systems. Surge protection devices can help protect sensitive electronic equipment from voltage spikes and surges. These devices divert excess voltage away from the equipment, preventing damage. Regular inspection and maintenance of electrical systems can help identify and correct potential problems before they lead to equipment failure or electrical hazards. Electrical systems should be inspected at least annually by a qualified electrician. When replacing electrical components, always use components that are rated for the same voltage and amperage as the original components. Using undersized components can create a fire hazard. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical work can be dangerous, and it's always best to leave it to the professionals. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. Electrical safety is everyone's responsibility. By following safe practices and adhering to the NEC and local electrical codes, we can help prevent electrical accidents and ensure the safety of ourselves and others. Remember that electricity is a powerful force, and it should always be treated with respect. When working with electrical systems, always turn off power at the breaker box before touching any wires or components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical systems when you are wet or standing in water. If you see any signs of electrical damage, such as frayed wires, cracked insulation, or sparking, contact a qualified electrician immediately. By taking these precautions, you can help prevent electrical accidents and ensure your safety. Furthermore, consider the impact of harmonic currents on the electrical system. Harmonic currents can cause overheating of conductors and equipment, leading to premature failure. Using harmonic filters can mitigate the effects of harmonic currents. When designing electrical systems, it's important to consider the load requirements of all equipment that will be connected to the system. This includes not only the steady-state load, but also the inrush current of motors and other inductive loads. Oversizing conductors can help accommodate inrush current and prevent voltage drop. The use of energy-efficient lighting and equipment can help reduce energy consumption and lower electricity bills. Consider using LED lighting and variable speed drives for motors. Power factor correction can improve the efficiency of electrical systems by reducing the amount of reactive power that is drawn from the grid. Power factor correction capacitors can be installed at individual loads or at the main service entrance. When installing underground ducts, it's important to consider the soil conditions and the potential for corrosion. Using corrosion-resistant conduit and proper backfilling techniques can help extend the life of the installation. The depth of burial for underground ducts is also important. The NEC specifies minimum burial depths for different types of conduit and applications. Proper drainage is essential for underground ducts to prevent water from accumulating and causing corrosion. The use of duct spacers can help maintain proper spacing between ducts and prevent them from rubbing against each other. When pulling conductors through underground ducts, it's important to use a lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the conductor insulation and the duct material. After pulling conductors through underground ducts, it's important to seal the ends of the ducts to prevent the entry of water and debris. The sealant should be compatible with the duct material and the conductor insulation. Regular inspection and maintenance of underground ducts can help identify and correct potential problems before they lead to equipment failure or electrical hazards. The inspection should include checking for cracks, leaks, and corrosion. When repairing underground ducts, it's important to use materials and techniques that are compatible with the existing installation. Improper repairs can lead to premature failure of the duct system. The use of trenchless technology can minimize disruption to the surrounding area when installing or repairing underground ducts. Trenchless technology involves using specialized equipment to install or repair ducts without excavating the entire trench. Before excavating near underground ducts, it's important to locate the ducts to prevent damage. Call the local utility locator service to mark the location of underground utilities. When working near underground ducts, use caution to avoid damaging the ducts. Use hand tools instead of power equipment when working close to the ducts. If you damage an underground duct, contact the utility company immediately. Do not attempt to repair the duct yourself. The utility company will have the necessary expertise and equipment to repair the duct safely and properly. Remember that underground ducts are an important part of the electrical infrastructure, and it's important to protect them from damage. By following safe practices and adhering to the NEC and local electrical codes, we can help ensure the reliability and safety of the electrical system. Also, proper documentation of the electrical system is essential for troubleshooting and maintenance. Keep accurate records of all electrical components, including their location, rating, and installation date. These records should be readily available to electricians and other qualified personnel. The use of a computerized maintenance management system, or CMMS, can help track electrical equipment and schedule maintenance activities. A CMMS can also generate reports on equipment performance and identify potential problems before they lead to equipment failure. Regular training for electricians and other qualified personnel is essential for keeping them up to date on the latest electrical codes and safety practices. Training should cover topics such as electrical safety, grounding, surge protection, and harmonic mitigation. The use of personal protective equipment, or PPE, is essential for protecting electricians from electrical hazards. PPE includes items such as safety glasses, rubber gloves, and insulated tools. Always inspect PPE before each use to ensure that it is in good condition. If you are unsure about any aspect of electrical safety, consult with a qualified electrician or safety professional. Electrical safety is everyone's responsibility, and it's important to take it seriously. By following safe practices and adhering to the NEC and local electrical codes, we can help prevent electrical accidents and ensure the safety of ourselves and others. Furthermore, consider the impact of energy storage systems on the electrical system. Energy storage systems, such as batteries, can provide backup power during outages and reduce peak demand. However, they can also introduce new challenges for electrical system design and operation. The NEC provides specific requirements for the installation and operation of energy storage systems. When installing an energy storage system, it's important to consult with a qualified electrician and engineer to ensure that the system is properly integrated into the electrical system. Also consider the impact of electric vehicle charging stations on the electrical system. Electric vehicle charging stations can place a significant load in the electrical system, especially if multiple vehicles are charging at the same time. The NEC provides specific requirements for the installation of electric vehicle charging stations. When installing an electric vehicle charging station, it's important to consult with a qualified electrician and engineer to ensure that the electrical system can handle the additional load. It's essential to stay informed about new technologies and best practices in the electrical industry. Attend industry conferences, read trade publications, and participate in online forums to stay up to date on the latest developments. By continuously learning and improving your skills, you can help ensure that you are providing the best possible electrical services to your clients. And remember, electrical safety is a continuous process, not a one-time event. By making electrical safety a priority, you can help create a safer and more efficient electrical system for everyone.